Hello Algebra 1 students, welcome to section 8-4 transforming quadratic function. Guys, in this section we're going to compare quadratic function every time to the parent quadratic function. So it's a good idea to start with revising all important characteristics of the parent quadratic function. The parent quadratic function equation f of x equals x squared, and it is represented by this parabola. This graph is called the parabola. This parabola has a vertex at the origin point 0, 0, and it has an axis of symmetry or line of symmetry, that line that divides the parabola into two parts, two symmetrical parts, and its equation is x equals 0. The equation of the y-axis is x equals 0, and we get this equation from the x-coordinate of the vertex all the time. Another characteristic is called zeros of quadratic function. The zeros of quadratic function occurs when the parabola intersects the x-axis. In this situation, the parabola only touches x-axis at one point at x-coordinate equals 0, so the zeros are only 1, 0. It has only 1, 0. The parabola opens, the opening direction of this parabola, guys, it's upward. It opens upward. You know, guys, parabolas open either upward or downward, and we can figure out this from the number in front of x squared. If you're not given any graph and you're only given the equation, you can look at this number. If that number positive, the opening direction is upward. If this number is negative, the parabola opens downward. Guys, this number in front of x squared is 1, and we use the letter a to refer to this number. So this a is very important. It determines the opening direction of the parabola, and also it determines the width of the parabola. How is that? Look at this, guys. I'm using online graphing a website. It's called desmos.com. Guys, you start with a coordinate plane like this one. This is a coordinate plane, x-axis and y-axis, and you can type the function in this box. So I'm gonna type y equals x squared. Okay, this is the parent quadratic function. You can change the color of that function any color you like. I'm gonna make it in blue. So my blue graph is the parent quadratic function, guys. This is the parent quadratic function. And now, guys, I'm talking about the width of the parabola. What determines the width of the parabola? The coefficient in front of x squared determines the width of the parabola. So, guys, let's try two different scenarios. Let's increase that coefficient and make it a number larger than 1. And let's decrease this coefficient and make it a fraction less than 1, and see what is going to happen when we increase and when we decrease that number. So, guys, I'm going to type another quadratic function with a larger coefficient. Y equals, for example, I'm going to make it 5x squared. I'm going to hide all of these, guys. So, guys, if you look at the blue graph is the parent quadratic function y equals x squared with coefficient 1. The coefficient of the original one is 1, and the new one with the coefficient 5, the red one with a coefficient 5. Guys, what happened? The new parabola, the red one, is narrower than the original one. This is opposite to my expectation. I expected when I increase this number, when I maximize this number and make it 5, I expected a wider parabola, but the result is a narrower parabola. Guys, what's going to happen if we decrease this number, if we make it a number less than 1? Now you can expect what's going to happen. So let me change that number. Let me erase that number and make it a fraction, for example, 0.2 fraction. Look at this, guys. Let me hide the keyboard. Look at this, guys. Our original parabola, the parent parabola, is y equals x squared with coefficient 1. And when I decrease this coefficient and I replace it by a fraction less than 1, 0.2 is less than 1, I got this red one, and the red one is much wider than the original one. So, guys, when you increase the coefficient, you get a narrower parabola. When you decrease the coefficient of x squared, you get a wider parabola. So now guys, in conclusion, we need to make a rule. The rule is, if this number a in front of x squared, if this number a is less than 1, you would see a wider graph. And if this number is greater than 1, if it's greater than 1, you would see a narrower graph. Guys, let's see our first example. In our first example, we comparing the widths of parabolas, and we don't even have the graph of the parabolas, we only given the equations, so we can only compare the coefficient of x squared in every function, so we can figure out the width of each one. Guys, if you get the absolute value of the coefficient of x squared in the first function, it's going to be the square root, the absolute value of 3 is equal to 3. And the absolute value of a is 0.5 in the second function, it's going to be 0.5. Why we get the absolute value? Because we don't care about the sign. The sign doesn't affect the width of the parabola, but the absolute value of the number determines the width of the parabola. Now guys, which one gonna be narrower, which one gonna be wider? Guys, as you seen in Desmos.com, the one with the larger number gonna be narrower, and the one with the smaller number gonna be wider. I need to order them from narrowest to widest. So f of x is gonna be narrower than g of x. Another example. This time we given three functions, f, g, and h of x. Each one of them is written in a different color, and again we need to order them from narrowest to widest. So guys, how do we know? From the coefficient of x squared in each function. In the first one, the coefficient of x squared is 1. It's invisible 1 actually. So the absolute value is going to be 1. The absolute value of half in the second function, g of x, is equal to half. And the absolute value of negative 2 in the last function is going to be 2. So guys, my concern is the absolute value of a. We're comparing the absolute value of a. Guys, h of x has the largest coefficient. It's 2. So this one going to be, yes, exactly, the narrowest one. The one with the largest coefficient is going to be the narrowest one. So when you order them from narrower, h of x is the narrowest one. The second narrowest one is going to be f of x. And the widest one going to be g of x, because it has coefficient less than 1. This is the smallest coefficient among 1 and 2, so this is going to be the widest one. So guys, it's really interesting to compare the width of functions without seeing their graphs. Guys, in this section you're going to learn how to transform quadratic functions, and the first type of transformation is called vertical translation. Guys, vertical translation, it means you move the whole parabola either up or down. How do we perform that? Look at Desmos.com another time, guys. And now let me start with the parent quadratic function y equals x squared. Guys, what is the effect of adding a number? Before we talked about the number multiplied by x squared, and it determines the width of the parabola. Now we're not talking about the width, we're talking about vertical translation. Vertical translation occurs when you add a number or when you subtract a number. So let's type another function. Let's type another one. Y equals x squared plus, I'm going to add a number this time, plus 5. Guys, look at this, but I need to change the color of this one. So let me make the second one color is red. Guys, look at this. My parent quadratic function in blue. When I added 5 to this parent function, the whole parabola shifted up 5 units. What do we call this, guys? It's a vertical translation. So vertical translation up occurs when you add a number. Guys, can you expect the situation when you subtract a number? Let's type another quadratic function, y equals x squared. This time I'm gonna minus a number. Guys, look at this green one. look at this green one, when I minus 2 from x squared, the blue parabola shifted down to be green and it was moved down 2 units. So guys, this is what we call a vertical translation, and it's very easy to recognize from the equation. If there is added number, it's a vertical shift up. If it's a subtracted number, it's a vertical shift down. 5 units up in this situation, 2 units down in that situation. Now back to our examples. So guys, in conclusion, if that number is positive, it's a vertical translation up. If this number is negative, it's a vertical translation down. In part A of example number 2, guys, we given the graph of two parabola, the graphs of two parabolas, and we need to compare them regarding to 4 characteristics. First, we need to compare them by the opening direction. F of x, the red one, opens up, and the blue one, g of x, opens down. We can recognize this from the graph or from the equations. G of x is translated. Guys, look at the blue one. The blue one vertex is shifted up 3 units. So it's translated 3 units up. Good. Another characteristic to compare the two graphs, guys, G of x is wider or narrower than f of x. Guys, apparently the blue one is much wider than the red one, so G of x is wider. Guys, consider if you start with f of x anytime, you need to change this word because f of x is narrower than g of x. Order is very important. The last characteristic, guys, you need to compare the two graphs is the line of symmetry. Line of symmetry is the vertical line that divides the parabola into two symmetrical parts. For the red one, it's y-axis. For the blue one, it's also y-axis, and its equation is x equals 0. So the line of symmetry of both functions, x equals 0. They have the same line of symmetry, guys. So guys, see you in the next part of this section. Study well.